Hello and welcome back to Differential Equations, section 4.4, derivatives, integrals, and products of transformations. We're short on time. So, the definition of the convolution of two functions is given through the integral. So this is a completely new operation that you've never seen before. So let's take a look. This is definition. So if you ask me, what is that? It's exactly what definition says. So convolution of two functions f and g, the piecewise continuous functions, is defined for all t's larger than 0. So here we go. Convolution of f with g of t. It's given as the integral 0 to t of f of tau times g of t minus tau d tau. This tau is a dummy variable. And this is known as convolution. This is for all t's larger than 0. And it's largely equal to 0. That's fine. Nothing, because the time doesn't go that way. Think of it at the beginning of time. It would be the same as asking what's south of South Pole. The answer is nothing. Right? All right, so now this is definition. What can we get out of this definition? The most interesting thing happens. We know that for integrals and derivatives, we have product rules, integration by parts, use substitution, and all of these things, because you cannot take the integral of two functions that are multiplied, integral of each one of them. That doesn't work. Now, the greatest thing about this is that the Laplace transform of f convolution g is Laplace of f times Laplace of g. So f of t, yeah. This is all of t. So what you get in the product of two Laplace transforms is the convolution of the original functions that give you those Laplace transforms. And convolution of two functions is given by that integral. You can actually sit and compute that. So let's we can compute some of these convolutions, but before we do that, the convolution, the property, convolution f convolve with g is g convolution f. And you can prove that obviously by using this thing. And then from here, Laplace transform, inverse Laplace transform of f of s times g of s is giving you f of t convolution g of t.
What exactly is convolution?
Do what?
What exactly is that?
I still don't know what a determinant is, so I don't care. That's that.
It's the operation that allows you to multiply Laplace transforms. So now, let's take a look at an example so it makes some sense. Well, I said what I'm going to say, and then the question came up, and I said it. Need the example. And time. Is everything okay over there? Who? Are you hungry? Do you have any of the soup left? Everyone's hungry. You have any soup left? Oh. Well, always was. All right. Problem number 4. F of t is given as t squared, and g of t is cosine t. Find the convolution. Yeah. Find f convolution g. Now you know it's commutative, so you can put g convolution f, same thing. All right, so what is our definition? F convolution g is going to be, in this case, t squared convolution cosine t, and that is integral 0 to t tau squared, because it's f of tau, and used to be t, now it's tau, times the cosine of t minus tau. D tau. Well, hello integration by parts 15,000 times, right? Well, twice, because tau squared. So we have u equals tau squared, and dv equals cosine t minus tau d tau. Du is 2 tau d tau, and v is integral of cosine is positive sine, so you have sine of t minus tau, and then you have to divide by -1, because tau is our main variable and it is negative tau in there, so it's divided by -1. Constant. T is a constant because integration in terms of tau. So now we have, won't fit here, so we go here. We have negative tau squared sine of t minus tau. Minus and minus give me plus, because the formula for integration by parts has a minus and then there's a -1. And now we have the integral 0 to t of 2 tau sine t minus tau d tau. And we have to do integration by parts one more time. U equals, I can kick 2 outside, let's drag it around, 2 tau, and dv is equal to sine t minus tau d tau. Du is 2 d tau when you differentiate, and over here you integrate to get negative cosine, but remember it will be divided by -1, so it's just cosine t minus tau. Right? Integral of sine is negative cosine, and you have -1 because it's negative tau over there, so those two minuses cancel. So the minus will survive this time. negative tau squared sine t minus tau plus 2 tau cosine t minus tau for the first part, and then minus the integral of 2 cosine t minus tau d tau from 0 to t. And finally, we can integrate the last piece and then apply the limits. So negative tau squared sine t minus tau plus 2 tau cosine t minus tau. Welcome to electrical engineering. Minus integral of cosine is positive sine. There will be a minus there from negative tau, so it becomes 2 sine t minus tau. All of this computed from 0 to t. Well, when you plug in t for every tau, right, because we are integrating tau out and now replacing the limits, it becomes negative t squared sine of 0 plus 2t cosine of 0 plus 2 sine of 0. And now we plug in 0. Minus 0 kills the entire term. Minus another 0 kills the whole term. And minus 2 sine, when you plug in tau, is just sine t. Right, because tau is 0 in the last one. So you have 1, 2, 3, 4, 5, 6. Good. Sine of 0 is 0. So first term dies. Second term, 2t survives. Cosine of 0 is 1. Sine of 0 is 0, 0, 0, and minus 2. So 2t minus 2 sine t. So convolution between f and g was 2t minus 2 sine t. Be that dramatic. How's your Calc 2?
I have a question. Why don't they tell us to take this class right out of high school and just take Calc 2 instead of waiting a year? All of that is forgotten. Didn't we use Calc 2 for linear algebra? You forget everything by the time we get here.
Let me say bye to everybody and say bye.